Let's talk about discrete random variables. The concept of probability is different from continuous distribution. So discrete variables, such as the outcome of rolling a fair die, take a specific separate values, so we can directly compute the probability of each possible outcome. So the possible outcomes are discrete values, which are countable and distinct. For a die, the numbers are from 1 through 6, and each outcome has a specific exact probability. So for a fair die, each face, which is 1, 2, 3, 4, 5, 6, has an equal probability of 1/6. So we can use a bar chart to represent these probabilities, with each bar showing the likelihood of rolling a specific number. The x-axis displays the discrete value that a die roll can result in, specifically the numbers from 1 to 6. Since the die is fair, each value has the same and equal probability, which is represented by the uniform height of the bar. The bar chart clearly separates each possible value, which emphasizes that there is no continuity between them, which is unlike the continuous distribution. This bar chart illustrates the probability distribution for rolling a fair die, and each bar represents one of the possible outcomes, which is 1 through 6, and each outcome has an equal probability of 1/6. So this visualization helps us to convey the fundamental differences between the discrete and continuous variable. In the discrete setting like this, we can assign and visualize exact probability for each distinct outcome. Let's try to further explore this concept of discrete random variable. So let's try to use an example of flipping a coin. So this scenario showcases how discrete random variables can have non-numerical outcomes, which in this case are heads or tails, and each outcome has a specific probability, which is particularly clear when we try to dealing with the simple binary outcomes like a coin toss. In this case of flipping a coin, the outcomes are non-numerical and consist of two possible states, which are heads and tails. So each outcome has an equal probability of occurring, typically 1/2 for a fair coin. So this contrasts with continuous random variable, which always have numerical outcomes and whose probabilities are defined over intervals. We just illustrated the probability mass function for flipping a fair coin. Each bar represents one of the two possible outcomes, heads and tails, and both outcomes has an equal probability of 1/2. Unlike the continuous random variables, the discrete random variable can have a non-numerical outcomes. So in this case, the outcomes are categorical rather than numerical values. The coin toss is a classical example of binary outcome with equal probabilities, which is ideal for introducing for basic probability concepts. The discrete nature of this random variable is emphasized by the fun fact that there are only two possible outcomes, and each of them distinctly defined and countable. So this visualization demonstrates the characteristic of discrete random variabilities effectively, which particularly their ability to handle non-numerical outcomes, which contrasting with the continuous random variables that only deals in numerical ranges and the probabilities which defined over intervals.